Welcome everyone to today's Hamptons Observatory program. I'm Dava Sobel. I'm a member of the Observatory's Advisory Board, and I'm pleased to welcome you all here. For those of you who are not familiar with the Observatory, we were established in 2005 to promote interest in science and especially astronomy. And lectures like the one you'll hear today are an important part of that mission. We offer all programs free to the public, never charge admission, and we are supported by voluntary donations. And if you want more information about the observatory, the website is hamptonsobservatory.org. We are also a bona fide astronomical observatory in the traditional sense, with a presence on the campus of the Ross School in East Hampton. And sometime soon, there will be a research grade telescope that will be available via the internet to students and amateurs and, again, the general public. And today I'm very excited to have with us Andy Lawrence, who is the Regius Professor of Astronomy at the University of Edinburgh. And he describes himself as an astronomer with a research interest in the physics of quasars, but also someone who enjoys outreach and arts collaborations and astronomical history. So he is my kind of guy. And I encountered him really first by reading his book, which you will hear more about. His book and today's lecture concern the same topic. And we often talk about light pollution and the need to preserve the dark sky. But there's also satellite pollution and the threat to observational astronomy and even casual stargazing from a superabundance of communication satellites. Now that the pandemic restrictions are easing, we find that Zoom has not outlived its usefulness. And it's thanks to that technology that we can bring Andy Lawrence here today, all the way from Scotland, for the space of this talk, and then get him home to Edinburgh before the hour grows late. And by that same technology, you can see him again next week, next Tuesday, June 15th at 2:30 Eastern Time, for a 2-hour live special discussion of this issue, losing the sky. And he will be joined then by many of his friends in discussion, including musician Brian Eno and the recently named Astronomer Royal of Scotland, Catherine Haymans. And more information about that event and ways to buy tickets are available on Andy Lawrence's personal website. So if you have questions as the conversation proceeds, put them in the chat box. We will get to them later on after the presentation. So now let me let Andy Lawrence speak for himself. Welcome, Andy.
Thank you very much for your kind words. It's amazing, the thought of giving a talk on Long Island, sitting here comfortably in my kitchen in Edinburgh. It's a very strange feeling, but a very pleasant one. So let me share my screen and we'll dive into to my talk. Now what we're going to do, hang on, let me get this going. Okay. Right. Now, there we go. You should be seeing the first slide of my talk. Everybody happy with that? Okay, cool. So today, my title, The Sky, Why It Matters and How We Might Lose It. So the talk is going to come in 3 parts. Part 1, is astronomy useless? Part 2, the threat to the sky, and part 3, what can we then do? So let me dive straight into part 1. Is astronomy useless? Now, I mean, I suspect everybody attending this talk has a negative answer to that question, but I think it's important to see the arguments. Okay, well, I see myself as a very lucky man because I've spent several decades of my career studying the sky and the objects in it. And these objects and the sky itself are very beautiful and they're intellectually fascinating. But you might worry that essentially the study of the sky is useless. Compared to, it's a distraction from the everyday affairs of the world and important matters of the world and our civilization, a kind of intellectual entertainment, as it were. So you might well believe that, but of course I believe that's wrong. So I'm going to spend the first part of the talk explaining to you why I think that's wrong, because I think it's quite important to get this in perspective. So we're going to start back in history and move forward to the current day and see the many reasons why the study of the sky and astronomy and the objects in the universe is important to us as a species. Okay, so back in history, first and simplest, for a very long time in human history, the study of the sky has been essential for agriculture. In order to know when to sow and when to reap, you have to understand the cycle of the year and the seasons. And the more accurately you understand that, the better. So we to eat, we have to understand the sky. Now, this won't be so popular with many modern astronomers, but another crucial reason deep in history is divination. Now, of course, in modern times, many of us will feel that this is all mumbo jumbo, etc. But it's undeniably the case that it's been crucial to the development of our species. And actually, I'd say astrology, I'm not too snobby about astrology because I see it as a kind of proto-science. It was originally part of the human desire to understand, control, and predict the world around us. So it was very important. Now, you may well ask, why is there a picture of the Crab Nebula there in the bottom right? So that, of course, is because in 1054 AD, Chinese astrologers saw a new star in the constellation of Taurus and took this to be of great portent. When we look there today, what we see is the shredded remains of a star that's exploded, a supernova. Okay, so divination. Moving forward a little bit in time, navigation is the other big historical reason why the study of the sky has been absolutely crucial. To know where you are as you move around the world, you need to study the sky quite closely. Now, of course, latitude is one thing. For longitude, as well as measuring the positions of the stars very accurately, you need to know the time, which is why Harrison's clock is there. And that brings me on to the next big reason. Astronomy has been crucial more and more through modern history for our grasp of time, keeping track of it, and the weaving of time into modern civilization. So there you see a train, and of course, once you had trains, then you had to know not just what time is it in Bristol, but what time is it in London. Coordinating the world, something was much more important. On the left there, and keeping track of time was the astronomer's job. for hundreds of years. On the left, what you see, this is in Edinburgh, this is the time ball on top of the Nelson Monument. So my predecessor as Regius Professor, Charles Piazzi Smythe, he started the time ball. So he had a clock, a master clock in the observatory. He observed the sky every night, or his assistants did, and those observations of the stars calibrated his clock. And then at 1 o'clock every day, he would lower the ball, and the citizens of Edinburgh would know it was exactly 1 o'clock. Okay, but the point was that, you know, we were developing clocks, of course, more and more technology, but to calibrate our clocks, we had to rely on the only really reliable clock we had, which was the rotation of the sky. Okay, so agriculture, divination, navigation, time. Okay, so that's all in history. Sorry, I went too fast there. So that's all in the past. So what about now? What's the role of the study of the sky in society today? So I'm going to kind of start fuzzy and become more hard-nosed as we go along. So at the fuzzy end, it's very important to have a sense of perspective. We think of, you know, where we live, the world, the universe that we inhabit. So it makes a difference to us psychologically, at least to most of us. So as an example of that, there's the Earth and the Sun, and understanding how much bigger the Sun is than the Earth puts things in perspective. So at the bottom right there, you see a perspex ball meant to be the Sun, containing roughly 1 million polystyrene balls, which are the Earth. Okay, so that's a nice physical representation of how much bigger the Sun is than the Earth. And then, of course, as we move out through the universe in modern times and understand the distance to the stars, the structure of the Milky Way, and the universe at large of galaxies and so on, we get lost even more deeply in the amazing universe that we're a part of. So at the top there, you see the Pleiades. So those are kind of, you know, nearest stars, amongst the nearest stars to us, and the stars behind there, the fainter stars, are much, much further away. Top right there, there's the Milky Way, angling across the northern sky as a picture taken in Caithness in northern Scotland. And I don't know about you, but you know, I love sort of lying on my back and staring at the Milky Way, because as you see this strip of light going across the dark sky, then you realize the truth of what David's often written about, you know, the great debate that happened at the beginning of the 20th century about the structure of the Milky Way, the universe we lived in, that we live in a giant disk of stars. So you can stare at the Milky Way and actually feel that in your bones, that this is your home. Of course, the Milky Way is very, very big. At the bottom there, there's a little section of an infrared survey that I was the PI of for mapping out the infrared emission from stars across the Milky Way. And if we look at this picture, with a bit of luck, this will move. There we go. So I just done a kind of pan across this to give you a sort of feeling for how many stars there are in the Milky Way. It's an awful lot, and that's only a tiny part of it. Okay, so perspective. Inspiration. So now I'm going to move rapidly from young children up to 18-year-olds. But on the left there, that's our brand new Astronomer Royal for Scotland, Catherine Haymans, with a school child making glitter galaxies, which is something we do at the Royal Observatory Edinburgh on open days. Great fun. There's another entranced child playing with light and prisms and so on. So inspiring young children and making them think about science and the nature of the universe around them. And then, of course, by the time they're 18, we get them into the universities and start actually teaching them. And astronomy is just a flavor of physics. And when we're at university, studying astrophysics is just as good as studying chemical physics or whatever you like. It's all about how the world works and understanding the principles of science. So there's one of my PhD students at the top of there, and telescope in La Palma, and that is the William Herschel telescope in the middle there, and then some random happy student pictures. Okay, so astronomers are of crucial importance to society because we train the young. That's a lot of our modern purpose. Okay, so now we move on to science and technology itself. So the thing is that science and technology is an undivided whole. It's not the case that astrophysics, the study of the stars and the galaxies, is a kind of a sort of intellectual fancy cake sort of built on top of this edifice of physics, right? It's inside the core of our understanding of physics and its role in our technological society. So the classic example of this in the 17th century is Newtonian physics, which of course is the bedrock of our modern technological civilization. So how did Newton come to his conclusions? It wasn't watching apples falling from trees. He may have done that. It came from worrying about the orbit of the moon. And how you could have a universal force that explained the motion of objects on the Earth, and it be the same laws of nature that explained the motion of the moon. So that was his goal. Then in the 20th century, atomic physics, quantum mechanics, electronics, all those things were largely driven by our desire to understand how stars worked. And even the mysteries of spectra that atomic physicists tried to understand, well, some of that was done in laboratories, but a lot of it originally came from looking at the spectroscopic studies of stars, how to explain the Balmer lines and so on, where the energy came from in the sun. I think it's fair to say, who knows whether quantum mechanics might have happened anyway, right? But it's undoubtedly historically true that astronomical concerns were at the base of driving people's curiosity and coming to understand quantum mechanics, atomic physics, and thereby a lot of the modern world and how it works. So is this going to carry on in the future? So right now, we're concerned and confused by dark energy and dark matter and all those mysterious things, which I don't have time to go into. At the moment, those things look kind of exotic and irrelevant to the rest of the scientific technological complex that underlies our world. But who knows? The thing is, this is long timescale stuff, okay? And I really wouldn't be surprised if once we've understood what is going on with dark energy and dark matter, that understanding will transform the whole of physics. And thereby will then foster a whole new revolution in technology, the way our everyday world works, just as it did for Newtonian physics and then building bridges, or the spectra of stars and then quantum mechanics and transistor radios. It can happen all over again. We just can't guess now. So the study of the sky is buried deep inside and mixed up with the whole of modern science and the whole of our modern society. So it's very, very far from irrelevant. Finally, won't take too long on this, but also the economy. Every day we have to justify what we do to our paymasters, as it were. Big modern astronomical experiments, space missions like the Hubble Space Telescope and so on, are of course hugely expensive. They are, and we're spending your tax dollars, and we're very, very grateful, I can tell you. But most of those many, many tax dollars that something like a big space telescope would cost, and not coming to people like me to pay my salary. That mostly comes from education. I'm paid because we're teaching the kids and doing the research as a luxury. No, most of those tax dollars come to us to build the amazing toys we're going to build and go back out to the economy into various sorts of industrial concerns. So it's kind of like building pyramids, if you like, but we are directly supporting the high-tech economy. Now, what's more, in doing that, we're extremely demanding customers. You know, at some point, the Chandra X-ray telescope, when that was being designed, and they wanted gratings to do X-ray spectroscopy, you know, so they went along to manufacturers saying, well, we want some gratings, but we want the ruling between the gratings to be 100 nanometers across. And they would have said, you're crazy, right? But they went and said, well, look, we'll give it a go. And then, you know, there was technological development and they did it. Likewise, at the moment, in planning the future of gravitational wave astronomy, we want to do that from space and not just from the ground. And to do that, you have spacecraft which are flying hundreds of thousands of kilometers apart, but have to maintain the distance between them very precisely, and for that to be known in order to make these measurements of gravitational waves. So to do that, you have to have incredibly difficult and careful ways of so-called station keeping for those spacecraft. But then that is something which, again, is driving the high-tech industry and will be useful for other things. So the demanding customer. But we're also early adopters. So, you know, astronomers were amongst the first people to use CCDs after they're invented. Likewise, the World Wide Web. So the World Wide Web was, of course, invented by our particle physics chums. But the European Southern Observatory was one of the very first websites after that invention. And finally, there is spin out as well. So a lot of several of the key components of Wi-Fi technology were invented by radio astronomers in trying to work out how to do fast communications in interferometry. And in the last few years, in my own institution up on Blackford Hill at the observatory, algorithms we were developing to compress data in sky surveys are now being redeployed in medical imaging. So, you know, these things are all very real. What's happening next? Well, here's one thing that's really happening interesting in California right now, so-called kinetic inductance detectors. Don't ask me to explain them, I haven't got time. But, you know, I think this is a very new kind of detection system that may turn out to be as revolutionary as CCDs. But, you know, we don't know where that's going. So I think that's, oh, no, it's not quite the end of part one. I will be brief on this, but now the new thing for us, and another reason why astronomy is important, is planetary protection. Killer rocks coming in from space. So we see the fireballs, we see the evidence like in Meteor Crater that things have walloped into the Earth in the past. And we know it could be catastrophic if that happens. We need to track all the big lumps and know what they're doing. That's done with wide field telescopes like the Pan-STARRS telescope in Hawaii. Here's a nice little GIF. You can see that asteroid. That's the image is moving, so the stars appear to be moving and the asteroid is staying in the middle. But of course, it's the other way around. So that's how you spot objects which are very close to us and might hit us. So to do that sort of work, and this segues nicely into the threat to the sky, which comes next. You need to take wide field pictures covering a lot of sky at once and look for and take successive snapshots and look for the things that are moving between the snapshots. So that's how we do a lot of astronomy these days. We like doing wide field mapping to get deeper and deeper pictures as we stack them. We look for things that change like supernovae, but we also look for things that move like near Earth objects. So that's how a lot of astronomy is done now. Okay, so hopefully, you know, possibly a lot of this audience wouldn't need convincing, but hopefully I've convinced you that astronomy is very far from useless. And for a lot of it, even if you started as astronomy fans, I hope a lot of that will be useful to you, because you know, if you're at parties or whatever and people say, well, what's the point of astronomy? You know, there's real world problems, and this is the sort of thing you can tell them. Okay, astronomy, for good or ill, it's part of the whole you know, technological industrial complex. It's all a part of the same system. Okay, so what's the threat? Well, just briefly, the threat we've known about for a long time, and I'm sure, you know, all the amateur astronomers know about, is simply bright skies from lighting, light pollution. This is a picture of taken from Mount Wilson in California, which, of course, at the beginning of the 20th century was just, you know, the most famous observatory. But now it's useless, because you see, these are the lights of Los Angeles. The sky is aglow because of that. Actually, this is a doubly horrible environmental catastrophe in this picture. It was taken in 2019. Not only can you see the lights of Los Angeles, you can see the forest fires as well. So it's pretty bad news. But anyway, I'm not going to talk anymore about that, because that's what's well known, of course. And the thing is, for us, you can, if you want to, you can escape it and go somewhere that's not in the middle of Los Angeles. You know, to a dark sky park such as we have here in Dumfries and Galloway, and hopefully, I know I've been hearing that, you know, there are nice dark parts of Long Island, so you can get away from it. But this is what you can't get away from, the new thing that is happening now. So there is a picture taken by the Dark Energy Survey camera, and it's got all these stripes across it. So what's going on there? That, as I'm sure you know, this is satellites from the SpaceX Starlink project streaking across the image. Bottom right there, one of my colleagues working on the Rubin Observatory project in Chile was taking a little selfie on the dome with his phone, and a satellite streaked through his phone picture as he did it. Then it's not just professional astronomers, it's amateur astronomy too. This is a picture taken by an astrophotographer from Czechoslovakia called Raphael Schmall. In the middle there is Beta Cygni, otherwise known as Albireo, with a whole bunch of Starlink satellites streaking through the picture during the exposure. As a piece of abstract art, it's quite beautiful, of course, but somewhat annoying. This is carrying on. This is just last month, one of my colleagues at the Astronomical Society of Edinburgh. This is a picture he took a short while ago. Just unexpected. Suddenly there were a bunch of Starlink satellites streaking across his image. Now you may think, okay, so we have to do astronomy from space, but no, you don't get away from it in space. At the top there is a recent picture from the Hubble Space Telescope, and one Starlink satellite passed relatively close by. I'm not sure how many kilometers it was, but probably a few hundred kilometers of the Hubble Space Telescope. And being so near, it was incredibly bright, but also defocused. And so rather than the thin streak, it makes a big fat stripe, which, you know, ruins a large fraction of that Hubble Space Telescope image. You may think, well, okay, so we've got to do other types of astronomy, like radio astronomy. But no, radio astronomy is worse. These satellites, to communicate with the ground, are sending down radio signals at frequencies that interfere with the radio astronomy observations. And they're billions of times brighter than the things that radio astronomers are trying to look at. You know, the way a radio telescope works is, you know, they'll have a narrow beam pointed at the bit of sky you're trying to look at, but there's always some kind of side lobe that will catch anything over in the side, like being kind of blinded out the corner of your eye, as it were, as a car headlight goes past you. So it's extremely bad news for radio astronomy. All right, so why are we suddenly making a fuss about this? Haven't there always been satellites? Yes, but the problem is getting hugely worse, and we'll gradually see why as I go through the next bit of the talk. So here's a couple of graphs which are taken from my book, which Davo mentioned. So the number of satellites has been growing steadily for ever since 1958 and Sputnik, of course. As of sort of middle of 2019, there are maybe something like 2,000 satellites in total, active satellites at that time. But in the last couple of years, the number has been suddenly zooming up. And almost all of the increase has been due to the SpaceX Starlink project in the last 2 years. They've now launched about 1,600 satellites. So they've almost doubled the number of satellites all by themselves in the last 2 years. Plus, they're all in low Earth orbit, and I'll show you why that's important in a minute. But basically, that's why they're so bright. Previously, a lot of these satellites were in geostationary orbit, a long way above the Earth, and so quite faint. But these are very bright satellites, and there's a huge number of them, and there's more and more of them. So the thing is, it's not just, although it's SpaceX right now, pretty soon it's going to be everybody and his brother, because loads of other companies and other countries are going, well, we better get in on the act. This is the competitive thing. This is the new space race. It's fleets, so-called mega constellations of satellites to provide internet connectivity. So in the UK, we got OneWeb. In Canada, there's Telesat, there's Roscosmos in Russia. Facebook and Amazon are doing their things. Another US company, Link, China, of course. Everybody's at it. So from a couple of different studies looking at the applications made to national licensing agencies and so on, people have estimated the number of satellites we're likely to have in a few years. And by 2029, it looks likely to be over 100,000. And remember, so in 2018, 2,000. 2029, 100,000. So this is not a trivial change. This is huge. And now, right now, the SpaceX people do speak to us, and they've tried to improve things a little bit, make their satellites a little bit darker and so on. But do we think that the people in Russia and China are going to listen to us if we say, oh, can you make that one a bit darker? It's just not going to happen. So we don't know where it's going to stop. It's really quite scary. So just to sum that up, what that means, having 100,000 satellites in low Earth orbit by 2029. If you imagine yourself looking with a pair of binoculars with a field of view about 7 degrees across, then every field pretty much you look at through your binoculars will have 10 bright satellites in, and they will be in a binocular field of view. They will be the brightest things in the field of view. So there will be typically 10 at any one time, and they'll take about 30 seconds to drift across your field of view, by which time, of course, there'll be some more coming in. Then in professional astronomy terms, if we take the new wide field telescope that is being built, the Rubin Observatory, pretty much every image will have 10 streaks going across it. For a radio telescope, over the whole sky in the local region, there'll be hundreds. And so at least some of them will always be making some sort of problem. So this doesn't obliterate the sky and make it vanish, but it is very, very bad news. And who knows where it'll stop. So right now in the USA, it's not legal to advertise from space. But we do not know whether that will continue to be the case if commercial pressure continues. And we cannot control the legislation in every other nation in the Earth. And once you put an advert into low Earth orbit so that it can be seen by billions of people at a time, there's not a lot you can do about it. So that's a bit scare story, but really we don't know where it's going to stop. And that to me is why this is so scary, because we don't know where it's going to end. Now, it's not just streaks in images or noise in radio telescopes. It's also making space itself difficult to work in. And so commercial space could be shooting itself in the foot if we're not careful. This graph here shows you the number of debris objects. So 2018, although there were maybe 2,000 active satellites, the total number of bits of junk that we were tracking was more like 20,000. And that's all the things that we can see down to about 10 centimeters. We can see them with our tracking telescopes. If you go down to millimeter size and flecks of paint and so on, we think there are probably millions of bits and pieces. And inevitably, this new generation of satellites is going to increase that problem. In fact, there was been several times over the last 3 or 4 times over the last couple of years, there have been close misses of possible collisions between satellites. So I don't try to do too much detail, but that problem is going to carry on getting worse. And there's a whole in our meeting next Tuesday that Dave referred to. There's going to be a whole section about the space junk problem. So what's this all about? You've probably heard it's about connecting the world, making global internet connection. And of course, the PR is that we can connect up world. Poor villagers in Africa and so on can have the internet. Now that's kind of true, but a bit misleading, because you don't have to make vast fleets of satellites to connect the world up. There are other ways to do it, with fiber or with a smaller number of high satellites. So why do you need many thousands? Roughly speaking, it's about a very specific internet use. It's about low latency, or at least this is the only rational justification for it, as opposed to sheer commercial aggression and competition. I'll show you a picture of why this is true, but if you want a very short delay time in the travel of your signals, there's 2 applications where this is important. Well, one is in high frequency trading. For the banks want to shave off a few milliseconds and be faster than the current undersea cables. Because if you can shave a few milliseconds off, then you beat your competitors. And at the other extreme, it's about real-time gaming, so that a farmer in Idaho can play League of Warriors with his friend in Belgium, but to have the motion realistic as you kind of raise your sword and try and whack people. For most other things, what matters is bandwidth. For video calls, streaming, ordinary web use, you don't need this. So why does this short delay, why does that need, so this is a bit technical, but I think you'll get the point. Why does that need thousands of satellites? So there are already companies that do satellite internet. So HughesNet, Viasat, Iridium, O3b are a few of the companies who've been doing it. Mostly they have satellites in very high orbits, so-called geosynchronous orbits that are many thousands of kilometers from the Earth. So the good thing about that is with one satellite, you can see a lot of the Earth's surface. So you only need a handful of satellites to provide coverage. But the bad thing is the travel time, even at the speed of light, going up to the satellite and back down, it's 120 milliseconds in each direction. So you can easily build up delays of a fraction of a second. Whereas now this is supposed to illustrate 500 kilometers a second where Starlink satellites are, and this is 1200 where the OneWeb satellites are. And they have very, very short time delays, which is what some of these use cases want. So that's cool. But then the trouble is, as you can see in this cartoon, any one satellite can only see a little bit of the Earth. All right. So if you're going to cover the whole Earth with this method, then you need thousands of satellites. So that's what they're doing and what is driving this. So it's not needed simply to connect the world. We can do it other ways. It is needed to have this, I'm going to say high speed. When people say high speed, they mean 2 things. Sometimes they mean bandwidth, how fast I can download my movie. That doesn't need the low satellites either. It's about very short time delays, fast speeds in that sense. That's what's driving this. All right, one final point and then on to what we can do about it. Excuse me. I kind of mentioned this in passing, but I'll try and drive this home soon. the old pollution problem, the light pollution, it's in some ways it's very obviously much worse. Once you live in the middle of LA, you can't really do any astronomy at all. It's just hopeless. But it's local. So, you know, at least for professional astronomers, we can build our telescopes in Hawaii or in Chile or whatever. We can get good work done. It's fine. If you're an amateur astronomer, an astrophotographer, you're okay if you live in Arizona. You're okay if you live in Dumfries and Galloway, but not in Glasgow, and so on. It's a local problem. This new problem, satellite pollution, is completely global. So here's the thing. You launch some satellites from California, and the USA has given you permission to do this. But an hour later, your satellites are flying over my head in Scotland or in somewhere in Namibia or whatever, okay? With people looking at the sky going, where'd that come from? Who said you could do that? Right? It's a global problem. And it's like, in that way, a little bit like plastics in the sea, except much, much quicker. So, you know, if you toss a piece of plastic into the sea off the coast of Long Island, eventually it'll end up in Mauritius and kill the fish there, okay? It just drifts around. So it's like that, but much quicker. It's a global problem. Okay, enough whinging. So part 3. As Lenin once said, what then shall we do? So I'm going to go through a series of options. So the first and simplest option is give up, roll over. You say, well, look, huge commercial forces. It's the way of the future. People want the internet. They're not too fussy about the pros and cons. You know, the US government is subsidizing this. You know, this is just a steamroller. Give up. Okay, so I think mostly I'm a kind of bend with the wind kind of guy in most aspects of it. But I think in this case, I think we shouldn't. I think that is not the right thing to do because it is frankly madness. Okay. Second possibility is protest or public awareness. So on the right there's a couple of petitions which are still active if you want to sign them. One is meant for professional astronomers and one for general public. So you can sign those petitions. It's also, of course, it's why I wrote this book, which is a non-technical book. So it's meant so that, you know, my cousin's hairdresser can read it and get something from it, as it were. So we can raise awareness and protest. And I'm sure that has to be part of the story, but it's not enough by itself. Yeah, so continuing the raising awareness theme, this is the event that Dave referred to. We're now next Tuesday at 7:30 in the evening British Standard Time, which is 2:30 East Coast US time. We've got a whole bunch of world experts debating this. So serious international experts and some of the people from some of the companies involved as well. And we're going to be having a debate about not just the effect on astronomical science, but also on culture and the environment, the debris problem, space law and policy, and so on. So it's going to be very exciting, and it's a debate between experts, but it'll be live on YouTube for members of the public to join in. So maybe a bit later in the chat window, I might put the link to the Eventbrite thing there. Okay, so that's enough of the plugs. Carrying on with what can we do? How about we speak to the companies and say, look, come on, it doesn't have to be quite this bad. Engage and mitigate, as we say. Now, this is the approach that most of my professional astronomy colleagues have been taking. We've formed working groups. We've had, telecons with the people at SpaceX. We've written a report. I say we. There's been a load of people. I've done very little of this, and now I've seen my job is writing the book. But many people have been working very hard on technical issues, writing a report that's gone to the United Nations. And so with SpaceX, that's had some success because SpaceX engineers, worked out a way to try painting a satellite black so that it's a little bit fainter, or of controlling its orientation so it's not quite as shiny at particular times. Those things have had some success, and they have made any one of these satellites maybe a factor 2 or 3 fainter. Now, for casual stargazing for a member of the public, if that could be enough to make them just below visible, but you'll still see them with binoculars, the astrophotographers will still see them, and for professional astronomy images, it makes almost no difference at all, because we're talking about things that are billions of times too bright, so a factor of 3 is not really a big deal. But those conversations are going on, and of course many people feel pragmatic, and that's kind of what we should be doing, is being reasonable and talking to people. But again, I'm not quite sure that's wise, because these are very powerful and selfish and aggressive forces that we're dealing with here. So I think we have to do this, but it's not the whole story. So what about Litigate? I mean, so in the US in particular, there's a very strong tradition when there are social injustices of one kind or another of suing people. Now, some people might complain that, in fact, the US society is a bit too litigious, but there's definitely a good side to that. So top left there, that's Erin Brockovich in the famous movie. Well, it's actually Julia Roberts, of course. Wonderful movie if you don't know it. So the whole idea of class action lawsuits, and it really helped to transform social justice in the USA, and that idea is catching on in Europe now as well. But that's all inside one country and in its legal system. So the thing is, at the moment, if I think, you've just ruined my sky, SpaceX, I'm going to sue you. As a British person, I can't sue SpaceX. Under what law? And I have no right to do that. Now, in coming to the final point, in international space law, there is a liability convention. But international space law is based around the assumption that states are responsible for what happens in space. And if private companies are doing things, then each state is responsible for the actions of its own private company. And that means that if somebody in France is cross with a space company in Brazil, then that person in France has to convince their government to take on the Brazilian government, and then the Brazilian government slaps the hands of the Brazilian company. Now you can imagine, and that's what the liability convention says in international space law. So it's been there for decades, and it's only been used once. A Russian satellite which contained a nuclear reactor crash landed in Canada. And after many years, so the Canadian government did get behind the local community there and pursued the Russian government, and eventually the Russian government paid some number of $1 million to the Canadian government. But as I said, that's happened exactly once. And right now, and we all know, we all were reading a few weeks ago about the Chinese rocket going out of control and thinking, where's it going to land? But other bits of space junk that are burning up on the way down but don't fully burn up. Suppose one of those lands on your roof. Who do you sue? It's not obvious at all what the answer is. And so one way or another, and I think this is going to be my final slide now, folks. But it'll take me a little while to talk through it. I think there is an international space policy and law and treaty framework. It's a thing called the Outer Space Treaty from 1967. And it stood us very well originally. And it kind of basically says states are responsible, and space is free for all to exploit for the benefit of all humanity, sort of thing. So very public spirited and nice. But the articles of that treaty and the follow-on treaties that have happened over decades don't really fit this new commercial age, with people like SpaceX and Amazon and Roscosmos diving in the classic business-like manner, doing what they are sort of kind of trained to do best, of trying to win a competitive edge, and only stopping if people make them. Okay, so the international framework is not really set up to deal with the new age that we're suddenly in. It wasn't relevant until private space companies like SpaceX started becoming successful. So things are changing fast. Now, if some of you are old enough, you may realize that this situation is a little bit like what happened to the law of the sea in the 1970s. Right, so 200 years ago, the official philosophy for the sea was pretty much like it is for space now. Every country had a kind of narrow coastal strip around it, and that was, that's our coastal waters, and the rest of you go away. You can't come here. That's our coastal waters. And then on the open sea, the philosophy was the freedom of the seas. Okay, and it was supposed to be open for all to exploit unhindered. And exactly the way that for the last 50 years we treated space. So that worked very well and helped trade for a long, long time. And then during the 20th century, it broke down. Cod wars. So, there were sort of aggressive battles between nations about who had fishing rights, because suddenly trawlers could travel huge distances, collect fish, and then bring them home again, which never happened before. Mineral rights on the seabed. Suddenly things were getting very nasty, competing over mineral rights. And at one point, the US government basically said, we lay a claim to the whole of the continental shelf that the US is attached to. And other countries were saying, what? And so it got very tense for a while, and something had to happen. So basically, during the 1970s, there was a big convention put together by United Nations, and this was thrashed out. Took a number of years, unfortunately, but at the end of all that, there was much improved international regulation and two new bodies which could settle disputes. The International Tribunal for the Law of the Sea and the International Seabed Authority. So that then had teeth in a way that space law doesn't. So what I'm saying is basically space law was set up in the 1960s for sort of gentlemen scientists, as it were. And now space is being pursued by aggressive business people. It just doesn't fit. So I'm pretty sure that what actually has to happen is that we will go through this kind of sorting out the culture and the laws that fit it and so on. But the problem is that's going to take quite a few years. It's very complicated. And what we do to stop the skies being completely screwed up before then is a much harder problem. So with a mixture of positivity and negativity at the end there, I think I'm going to stop. So thank you.
Thank you, Andy.
Thank you. Thank you for that truly enlightening talk. In my excitement at the beginning, I forgot to mention that we are being co-sponsored today by the South Fork Natural History Museum. And I do want to express the observatory's thanks for their joining in this. And as moderator, I'll take the right of first question and ask you what you think about what we're doing right now by Zoom, and how this plays into the problem. Are we part of the problem by meeting this way?
Yes and no. So it is true that we've all come to expect more and more. In the same way we do, we expect in our stores to have strawberries at any time of year and so on, and things flown in, and we've just come to expect more and more sort of ease and comfort and pleasure in our lives without being careful enough about what the cost of those things is. So in that sense, we are part of the problem, because as ordinary people, as consumers, we're more and more demanding, including certainly, I want to play League of Warriors with my friend in Belgium, etc. Okay. Now, on the other hand, literally what we're doing now, having a video call connection, that takes quite a lot of infrastructure, but I'm pretty certain that it does not take thousands of low Earth orbit satellites. So in that sense, it's not that we have to give up having Zoom calls. I think that is not necessary. So yes and no. In a way, just like all the rest of the problems of living in modern day capitalist societies, of course, as consumers, we have responsibility as well as getting the benefits. We have to recognize what we're tied up inside. There is, I mean, just to pick up on that, it is clear that when you sort of see what people are saying on Twitter or Facebook or whatever, the ordinary people are quite divided, because there are lots of people who see pictures of the satellites or see them in their own back garden and go, "What? This is terrible!" And there are other numbers of people saying, "What's the problem? We need internet. So give me my internet."
Yeah.
And it's quite divisive amongst ordinary people.
What is not divisive these days? So let me just say to the participants, if you want to ask a question yourself, to have your video and mic activated, just put that into the chat so we know to turn you on and let you ask. The one question I see in the chat, but I think you've already addressed this, but is there a legal way to preemptively prevent this pollution of the commons? This is from James Salmon.
Yeah, well, so I think I kind of half covered that, but it is such a good question, and it is the core of the issue. There isn't, right. There are several problems here. One is the way the international law is set up. It's quite hard for one nation to control the activities of another nation if it's doing difficult things, or especially for individuals in one nation to challenge the activities of individuals or companies in another nation, because the whole of international law is built around states, and it's not supposed to be you or me, only through lobbying our governments. So that's one problem, that's not sufficiently set up. Now, you might say, on the other hand, that law is doing its work because SpaceX have to jump through lots of hoops to be allowed to launch within the USA, and other companies quite often fight them, and there are. But the problem there is what a body like the Federal Communications Commission, who give SpaceX permission, that things that they don't expect to take into account the issues of astronomers or amateur astronomers being crossed because we're losing the night sky. It's not officially an environmental issue that they have to consider. It's not part of US law. There's a lot of, there's people, some people are contesting that now, but it's not an environmental issue that has to be protected against. Or the issue of overcrowding space and the space junk problem. So that's part of the problem. Those things should be, that's, from international pressure, what we should consider. But the really big problem, I think, at the end of the day right now, I'm sorry to say this, but it's a bit of a US problem, because the US government is positively subsidizing these things because it wants to make, honorably, it wants to make good internet connections for as many of its citizens as it can. And once the US decides it's giving permission to SpaceX, there's not a lot I can do about it. So I think in the short term, I fear there's not a lot to do. But in the longer term, I think we can make an international sort of movement that builds towards having a better regulatory framework that will stop it getting worse and worse and worse. So it's a question of timing.
So do citizens need to, especially citizens in the United States, need to agitate for wider awareness that this is an issue that needs to be legislated? I mean, it seems we're very far away from the long-term solution, and the steps to get there would involve a lot of awareness raising.
Indeed, that's exactly it. It's all about, because I know companies have to do what governments tell them at the end of the day, and governments like to listen to their citizens. So if they think that nobody cares, then nothing will happen.
Go ahead.
So exactly, people have to agitate and say, we do care, this matters, we care. That is exactly what has to happen.
There's another question from Patria Barati Pattis. Do you know if there are other forces outside the United States that can police this issue?
No, and I'm not quite sure what the questioner means by Space Force police. Actually,
it really said, do you know if there are other Space Force police other than the US? So I'm not quite sure either, because
yeah, we could do we put that person on and see if they want to say a bit more about what they mean? If they don't have to, but if they wanted to speak, they could.
Here we are. Unmute yourself.
The United States formed a space police, I thought. Didn't we? Space Force police to police the space? As far as I know, we did.
Not quite. So there is now a Space Force, which is like part of the armed forces. Okay.
Right.
And that really was a renaming of what is a part of for a long time, part of the US Air Force, which was called the Space Control Squadron or something like that.
Right.
Right. And that's now called the Space Force. They're
Right.
not really a police force. So they do a fantastic job in that they they all those bits of junk I was talking about, they're the people who track them. So they have telescopes and they watch them and they keep a database and they hand out that data to the world so people know what's going on. So that's a great thing that the US military does, and that's what the Space Force is. So they track, but they're not a police force in that they don't tell people off or punish them if they do bad things.
Oh, okay. I thought it was like eventually that was what the premise, because things are getting out of hand up there. So my take was if somebody is trying to, hypothetically, let's say if somebody wants to get rid of our satellite, there would be, I guess, discussions or how to deal with, because we are getting smaller in the universe. So eventually, since we're polluting the earth, we're polluting the, as you said, with the light pollution up top. So I'm thinking, I thought maybe some countries would get together and talk about policing the earth. I'm sorry,
Right.
the universe.
That is what we're talking about, and it has to begin with individual efforts to pressure governments all over the world to make this a priority.
Yeah. So okay.
Well,
Okay,
one thing
thank
that
you.
makes me think of is a little a tricky thing about space law. You know, so in most countries, if things are junk which is left around by people, you know, you can salvage it and resell it. People have abandoned something. You know, you have, in most countries, you have the right to kind of take it and, you know, melt the metal down or whatever you like, right? That's salvage operations. That's a legal thing that can happen. You can't do that in space. The international treaty says that any satellite, even when it's dead and so can't be controlled anymore, it still belongs to the people who launched it, and you're not allowed to go up and collect it. Because there are some very interesting companies who are developing spacecraft that in principle could go up, grab hold of something and pull it back down. Right? So, you know, we have the technology to do that now, but legally you're not allowed to do it. So that is one little detail of, and if there was a kind of international police force, as it were, then you could, in the same way that, you know, the city police might say that car's burned out and been sitting there for months, we're going to take it away. You know, maybe something equivalent to that will happen eventually, but it's got a way to go.
Thank you.
Thank you. Well, this has been terrific. We're so grateful that you're able to join us. And
my pleasure.
We, I hope many of us will see you again next Tuesday at your special event. We'll send a notice to the observatory mailing list so everyone knows about it. And
that would be lovely. Thank you.
I'm so grateful and just wish you well. We're all now informed, and we'll try to do what each of us can do.
Just one last closing thought.
Yeah.
Some of my colleagues in the sort of space law and policy areas have talked about the possibility that what we need is kind of the equivalent of Greenpeace for space, as it were. A campaigning, or maybe Friends of the Earth is a better example. I'm not sure which is more in favor, but some kind of campaigning organization that ordinary people can join and volunteer for and help to lobby. So I think, you know, so that might come along and could be useful and interesting.
Friends of Space, something like that.
Friends of Space, something like that. Yes, yes.
Okay.
Right. So when it's done, we'll sign you up, David. There we go.
I'm going to sign up already. This may be a mission to get that rolling.
Excellent.
All right. Thanks again. Thanks to everyone who joined us, and we'll see you next time.
Bye-bye, everybody.
Bye.
Well, there we go.
Thank you much. Thank you, Andy. That was really great.
My pleasure.
Learned a lot.
I'll go and have the rest of my dinner now.
Definitely. Thanks for giving us your time. I know it's a long way away.
Yeah. Right. Thank you. It was nice to be there. And one day I'll see you in person.
Okay.
Okay. Bye-bye then. Bye.